All right, now we're on to trig ratios. So in this section, we're going to be talking about all of the different fractional ratios we can create from the sides of a right triangle. And then we're going to use those trig functions. There's three of them. We'll use them to solve for some missing sides or some missing angles in the triangle. So we'll start this off with talking about the three main trig functions, and we'll go through each one individually, but just to highlight them first here, you have the sine function, which has an abbreviation of sin, but is still said or pronounced the same way, sine. So it's not sin, it's sine. The cosine function, and its abbreviation is cos, and it's still pronounced cosine, even though it looks like cos. It's not cos, it's cosine. And then the third one is tangent, and its abbreviation is tan, and it's still pronounced tangent. You don't pronounce it tan. So when you're talking about these three functions, you're not saying sin, cos, and tan. That makes you sound foolish. You're saying sine, cosine, and tangent. That makes you sound intelligent. So as we go through these, just remember that. Let's start off with sine, and let's read about what it does. So it says in a right triangle, angle A is an acute angle, and we have a little picture here with angle A as an acute angle. And then we have three sides in the triangle, this right triangle, and we're going to first find the sine of angle A and then the sine of angle B, and it's going to involve a ratio, so a fraction. And anytime you're dealing with sine, you are dealing with the opposite side over the hypotenuse in your triangle. Now, when we say opposite side, we mean from whichever angle we're referencing. So right now, the first one is referencing angle A. So sometimes in the beginning, what I like to do is draw a little stick figure here and say, if I'm standing at angle A, then the opposite side is 22. That's the opposite side from angle A. So then my sine of angle A would first get me 22 for the opposite side, and then I would take that over the hypotenuse. In this case, the hypotenuse is 28. So 22 over 28. And then always, 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 when you have a fraction, reduce it if you can. So this one would reduce to 11 over 14. And that would be the sine of angle A. And not always is it written as sine of angle A. Sometimes we'll write it as what's the sine of A, and we just forget the angle symbol. So either way is okay to write it. The sine of angle B now, I'm going to erase my stick figure and my arrow, and I will change positions. Now I'm referencing what if I am standing at angle B, and the sine is still the opposite, so I'll go opposite side of angle B. In this case, that's 11. And then the hypotenuse has not changed. That's still 28. Only this time, this does not reduce. So then that is my ratio for the sine of angle B. Don't try to stick anything in your calculator at this point. You're just writing out ratios and reducing them. Let's go to the cosine. So I have, again, the cosine of angle A and the cosine of angle B. We will never find the sine or cosine or tangent of the 90-degree angle, so you will not worry about referencing from the 90-degree angle. That you will do whenever you get into the actual trigonometry class. So the cosine of angle A is now the adjacent side over the hypotenuse. So the adjacent side is the side next to where you're standing or you're referencing from, and it's not the hypotenuse. So in this case, we're standing at, again, angle A, and the adjacent side would be the side that touches angle A but is not the hypotenuse. Well, that's this side right here at the bottom. So the cosine of angle A is 11 for the top part, the adjacent part, and then the hypotenuse is 28 again. So adjacent over hypotenuse, 11 over 28, it does not reduce. Now notice, that is the exact same answer that we got up above for the sine of angle B. There's some patterns here, and I'll let you see them if you can find them, but I'm just pointing this out to you. The cosine of angle A is exactly the same ratio as the sine of angle B. There's a pattern there. The cosine of angle B, now let's get rid of my figure, and let's also get rid of my highlight portion here. If now I'm referencing angle B, then the adjacent side to angle B will be the side that touches angle B, but it's not the hypotenuse. That's this side now. So the adjacent is 22 over the hypotenuse is 28. That does reduce to 11 over 14. And that one's finished. So notice again, if I scroll back up here, the sine of angle A and the cosine of angle B are exactly the same answer. So there's a little pattern there. As we get through these, kind of go back and double check that pattern and see what's going on. It can save you some time in the future. So that's the sine and that's the cosine. The tangent uses the opposite side divided by the adjacent side. So no more hypotenuse for this one. So the tangent of angle A, I'm going to reference from angle A. And if I go opposite again, this is 22. And then this time the adjacent side will be this side touching angle A, but that's not the hypotenuse, so 11. So then this one ends up being 22 over 11. And that one reduces down to 2 over 1, but you can just write 2 if you want to. And then get rid of this stick figure here with these arrows. And I will now go reference the tangent of angle B. So if I'm standing at angle B, then the opposite side is 11 and the adjacent side is 22. So now it's 11 over 22, and that is 1 over 2. So don't get that one mixed up and reduce that down to 2. It's 1 over 2. Okay, so there is a nice, lovely mnemonic that you can use to remember this, and it is SOHCAHTOA. So SOHCAHTOA. So the S, the C, and the T represent your sine, your cosine, and your tangent. And then your O and H and A is the opposite, hypotenuse, and adjacent. So this would be sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and then tangent is opposite over adjacent. So if you are getting ready to start a quiz or your homework and you want to write SOHCAHTOA out, then that will help you remember what each one is. You just have to spell it correctly. It's SOHCAH and then TOA. So SOHCAHTOA. Moving on, let's use this on a triangle. It says, find the sine of f, the cosine of f, the tangent of f, the sine of d, the cosine of d, and the tangent of d. So notice we're not finding the sine, cosine, or tangent of e. We're finding the sine, cosine, and tangent of the two acute angles. And then it says, express each as a ratio, each ratio as a fraction, just like we did a second ago, and as a decimal. Round it to the nearest tenth. Okay, so if I want to express it as a fraction, we've done that. We haven't done it as a decimal yet. So let's run through these. The sine of f, I'm going to go a little bit faster here. So if I'm referencing f, remember the sine is, let's just write these out, opposite over hypotenuse. Let's do cosine here is adjacent over hypotenuse. And then the tangent is opposite over adjacent. I really highly suggest you trying to memorize that because you're going to use it so often that it's going to come in handy if you do. So I've got the 3 written out there, so when I hit them, I'll know exactly what to do. So the sine of f, we can go opposite of f is 3, hypotenuse is 5. So this would be 3 divided by 5. Let's just do the fractions first. So sine of f, 3 over 5. Now, I'm not going to draw it every single time because I'm going to have to erase every single time. So the sine of D, I reference from D, and I go opposite of D, that's 4. Hypotenuse is still 5. None of these reduce. Tangent of F is the opposite over adjacent. So go back to F, opposite 3. And now the adjacent is 4 because it's not the hypotenuse. So 3 over 4. And then the tangent of D, I'm going straight across. Go the opposite of D, that's 4. And then the adjacent is 3. So it's basically the flipped version of the tangent of F. Cosine of F is standing at F, adjacent is 4. It's the one that's not the hypotenuse that touches F. And then the hypotenuse is 5. And then the cosine of D is adjacent 3, hypotenuse 5. Now let's make some pattern recognition here. So notice these two are let's do a highlight. Go to my highlight. Notice these two are the same. Let's do the actual thing. So these two are the same. Different highlight. Let's notice that these two are the same. Okay, we talked about that in the previous page. So quick and easy if you need to if you need to find the cosine of F and you know it should be the same as the sine of D, then you can just write it down without having to think about it too much. And then let's do the decimal versions. Oops. So 3/5. All you're doing in your calculator is putting 3 divided by 5 in your calculator. You don't have to do anything special. There's no function. Don't hit the function key yet. And that is rounded to the nearest tenth. That's 0.6. And then 4/5, put that in your calculator. Rounded to the nearest tenth is 0.8. And then 3/4, rounded to the nearest tenth. I guess I should do, this is also 0.8 because it's 0.75 rounded up. And then the same ones happen over here. 3/5 rounded is 0.6. 4/5 rounded is 0.8. And I don't know if those round or not because I'm using numbers that I've already gotten. And the tangent 4/3 is rounded to 1.3. And then there it is. That's the fraction and the decimal. So pay attention to what it asks you to round to. Let's use a calculator now. So you need to have your calculator handy, and you can use your phone if you turn it to a little scientific calculator, if you just turn it on its side, or if you have your own calculator, that's great. You need to have a calculator that has the sine, cosine, and tangent functions in it, and your phone calculator would do that. There should also be one on your Chromebook if you have one. So use a calculator to find the value of the following to the nearest 10,000th. Well, remember the decimals go tenths, hundredths, thousandths, 10,000ths. So that's 4 decimal places is what we'll round to. And in this case, if I just punch in my calculator cosine of 39, so it depends on what calculator you might hit the cosine button, hit the COS button on your calculator, and then punch in 39 and then hit enter. Or if you're using your phone, you may have to hit the 39 first and then hit the cosine button. Just figure out which way it works, and then the answer that they give you should be rounded to the nearest 10,000th, which would get you 0.7771. Now, if you don't get 0.7771, you get something else. You may be in radians, and you should be able to get out of radians if you change. Kind of depends on what your calculator is, but you'll have to change your mode and go in and change it to degrees instead of radians. Sometimes there's a DRG button that gets accidentally pressed on your calculator, and that will transfer you from degrees, radians, and graduate, I believe, is the other one. So change it to degrees. Cosine of 67, simply punch it in your calculator and see what you get. You should get 0.3907, and then that's it. That's as simple as just punching it in your calculator. Let's use this to find missing lengths now. So we've done ratios, we've done decimals, we've punched it in our calculator. Let's do some word problem type of things. So you can use trig ratios to find the missing measure of a right triangle if you know the measures of two sides, or you know the measures of one side and one acute angle in a right triangle. So here's the word problem. Drew is standing on the ground 97 yards from the base of a cliff. So that means Drew is standing over here. Using a theodolite, he noted that the angle formed by the ground, so the angle formed by the ground and the line of sight to the top of the cliff. Okay, this is the top of the cliff. So he noted that this angle was 56 degrees. Find the height of the cliff. So find the missing height of the cliff. Let's call that x. So what we want to do is in the picture, so if there is no picture, you want to draw a picture. It's going to create a triangle. We want to note where we're standing. So we're standing at this angle at the bottom left. We have the opposite side, or I guess we don't have it, but we want to find the opposite side. We have the adjacent side of 97. So opposite and adjacent are what our triangle deals with, and we have an angle. So we want to use whichever function deals with opposite over adjacent. And if I write out the mnemonic SOHCAHTOA, the opposite over adjacent ends up being the t for tangent. So we're going to say the tangent of the angle that I'm standing at. In this case, it's 56. Sometimes you might not know what it is, so you can call it x. So the tangent of 56 is equal to the opposite side, which we are looking for, x, over the adjacent side of 97. So we now have to solve this. How you solve this is you get x by itself. Well, to get x by itself, the very first thing you have to do is get rid of the denominator by it's being divided, so multiply it. So 97 gets multiplied on both sides. So these 97s will cancel out. I am left with, on the left side, 97 times the tangent of 56. And notice if I just write them next to each other, it means multiplication. And then that is equal to x. So then I can put that in my calculator and just straight up the same way it's written, 97 tangent 56, your calculator will know to multiply. And that is going to get me a value of roughly, and this one says find the height to the nearest yard. So if I round it to the nearest yard, that is roughly 144 yards. Okay. Now, another way they could have given this to us, let's say I didn't have how far away this person was. So this is now like kind of an addition to this problem here. So let's say I didn't know how far he was. So let's say that's 97, and let's say I did know the height. Let's pretend this was 144. So I'm kind of switching around the problem just to show you another way that you might have to solve it. So it would still be opposite over adjacent, only this time it would be tangent of 56 is equal to what I know, 144, over what I don't know, x. So it's the same. I'm writing this the same way, I just have different numbers. So if you get this, you do the same exact process. I would multiply by the denominator to get rid of it, and in this case, the denominator is a variable, so sometimes this just looks weird for students. So if I multiply by the denominator, that would get rid of the denominator on the right side, the x's, and that's okay to cancel them out because you have an x on the left side. So you would have x tangent 56 is equal to 144, and then you would solve for x, which means you would get rid of the tangent 56. Now the tangent and the 56 go together, so you'd have to get rid of the whole thing by dividing by the tangent of 56 altogether on both sides. That means these are going to cancel out, and what you're going to put in your calculator is this 144 divided by the tangent of 56, and it should get you what you started with, or what we started with in the beginning, which is roughly 97 yards. Okay, so that's just another scenario that you might have where your denominator or your bottom number is a variable. Let's use a calculator to find out what the missing angles are. So if I have the sine of an angle A and it's missing and it equals 3/4, and they want me to find angle A, then we will move the sine over to the other side. Now this is just a property. I'm not dividing or anything. This is just a property. If I move that sine over to the other side, the angle A is by itself on the left side, and now the sine becomes a sine inverse. Now, when we say sine inverse, we mean sine to the -1 power here. Now, that's a button on your calculator. So all this is saying is you are now going to use that button on your calculator, and whatever was already over there, in this case 3/4, will stay over there, and I have the sine inverse of 3/4. So in your calculator, you're going to hit the second sine, that's the sine inverse, and then you're going to hit 3 divided by 4, and then hit enter, and it should give you a value for the angle. And in our case, I'm going to go ahead and round it to the nearest tenth. It would be 48.6 degrees, and that's our missing angle. So then this next problem, we want to find angle B, and I have a decimal over here to the right side, and that's totally okay. But what I do first is I move the tangent over using the property of moving it to the other side, and when I do that, it becomes the tangent inverse of what's already over there, in this case 0.4279. So in my calculator, I'm going to put second tangent and then 0.4279, and when you punch that in, it should give you 23.2 degrees. And that's how you find missing angles. So if we were doing this problem up above and we were missing the angle, that's how we would solve for the missing angle, because it would probably give us something like this first one here, and then I would have to move the sine over to make it sine inverse and then punch it in my calculator. And that takes care of trig ratios and everything involved with those.